Okay, so let us solve together this question on how to write the net ionic equation, basically in chemistry. So how do we write the net ionic equation? So I will give you the procedures on how to write the ionic equation. Okay, so what are the steps are you supposed to follow when writing the ionic equation? Okay, in this case, the other steps have already been done for us because the equation is already given. Because the first step is writing the correct chemical equation. Then number two, we need to balance the chemical equation. So in this case, if you look at the first question, we have hydrochloric acid, which is the HCl plus NaOH. This is sodium hydroxide to produce sodium chloride plus water. Okay, so to write the net ionic equation, we need to rewrite this equation. So this will be, okay, excuse me, this will be hydrochloric acid plus sodium hydroxide to produce sodium chloride plus water. Okay, you need to write the the state symbol. So that is aqueous, that is also aqueous, that is also aqueous, and then this is a liquid. Okay, so to write the net ionic equation, you need to balance the chemical equation. You have to make sure that the atoms which are on the left side of the reaction is equal to the atoms on the right side of the reaction. Okay, so we start counting. You can see hydrogen here. We have two atoms of hydrogen. Here there is one, here there is one, together two. Here we have two hydrogen. Okay, hydrogen is balanced. Chlorine, here we have one. Here we have one, it is balanced. Sodium, here one, sodium is balanced. Oxygen one, oxygen one. So in this case, this equation is already balanced. Okay, so this one has already been balanced. It's quite easy for us now. When you balance the chemical equation, you need to write the ionic equation. How do we write the ionic equation? The ionic equation is written by splitting the atoms for molecules or substances which are in aqueous state. You need to split the atoms or radicals which may be present from the substances which are in aqueous state. So you need to know what makes up sodium hydrochloric acid, what makes up sodium hydroxide. Okay, so hydrochloric acid is made up of hydrogen and chlorine, so you need to split these two. Okay, so when splitting, these going to be ions. So we have hydrogen, we are cutting that one at the middle, we are splitting these two. So now you need to show the valency on top in form of charge. Okay, so that means the electron which this hydrogen has lost. Hydrogen loses electrons when it is it becomes a positive charge solely when it is in molecular compounds in the absence of the metal. Okay, so this forms a positive charge, hydrogen. Hydrogen of an acid always has a positive charge, don't forget that. Then plus hydrochloric acid. In this case, it will be a chloride ion, which forms a negative charge. Non-metals always forms a negative charge, except for hydrogen in the absence of the metal. Then plus sodium. Okay, sodium forms a positive charge. It is a metal found in group 1, so it's a positive charge. Then plus hydroxide, we are cutting that, so plus hydroxide, which is also negative charge, which is going to produce sodium. So all those which are in aqueous state, you need to split them. So sodium positive plus chloride negative. Now the substances which are in liquid form, which are in gaseous form and solid form, you are not supposed to tamper with these. Do not split them. So you cannot split this because it is in liquid form. We only split those which are in aqueous state. So water will still remain the H2O as a liquid. So all these ions which has been splitted are in aqueous state. Okay, so all these are in aqueous state. Okay, now this is the ionic equation. Now for it to be the net ionic equation, you need to omit the ions which looks exactly the same from the from the left side and to the right side. Okay, that's L. Okay, so from the left side and the right side. So you need to omit these ions which looks exactly the same here, which are called the spectator ions. So you need to remove the spectator ions. Spectator ions, these are ions which have not been changed, which looks exactly the same from the reactant side and the product side. So if you look at this, you will see that okay, hydrogen has been changed. You can see we don't have any hydrogen which looks like this. Chlorine, this chlorine looks exactly the same as this one, so we have to omit this one. You need to remove that, cancel them out. Check another one. So we have sodium, sodium positive, sodium positive. This one also looks exactly the same. That's all. We have remained with the hydrogen positive, which is in aqueous state, plus hydroxide negative, which is in aqueous state. This produces water as a liquid, the H2O. Okay, so this is the net ionic equation for this reaction which we have been told to answer. Okay, so it is as simple as that. Do not forget you need to balance the equation. Then when you balance, that's when you start splitting the substances which are in aqueous state. Okay, quickly let me also go through the second one. B, we have sulfuric acid plus barium hydroxide to produce barium sulfate plus water. Okay, so this is a liquid, barium sulfate is a solid. Okay, about the state symbols will become good when you do salts, because the types of salt will help you to know the state symbol. So if you look at this one, this is an insoluble salt. That's what I've written is solid here. This is aqueous. This is also aqueous. So for you to write the ionic equation for this one, the net ionic equation, you need to balance it. Count the atoms. Check. Here we have hydrogen. How many hydrogen here? We have two together 4. We have 4 hydrogen. Here we have 2 hydrogen. So it's not balanced. So how can we balance? Going to put a 2 there so that we can have 4 hydrogen. Okay. Sulfur here it's 1. Sulfur is 1. Oxygen here it's 4 plus 2. We have 6. Okay. Here we have 4. This also is 2 for hydrogen, for oxygen as well. So 6. Oxygen is balanced. Barium 1. Barium 1. So the equation is balanced. Now we need to start splitting the substances which are in aqueous state. We split the substances which are in aqueous state for us to have the net ionic equation. Okay, so we have hydrogen. So now these 2 for hydrogen will not be here. For it to be, since it's an ion, the 2 will be written in front. So we have 2 hydrogen, positive, don't forget the positive, plus sulfate radical, sulfate ion, which is 2 negative, then plus barium positive, 2 positive, it has a valence number of 2. Okay, then plus hydroxide. So the 2 for hydroxide will also not be here, will be in front. So 2 hydroxide, which is negative, to produce barium sulfate. This one is not good. We are not supposed to split this one. Do not split this one because it is in solid state. Okay, so barium sulfate, which is in solid state, plus do not split this one again, is a liquid, so it will just be like that, 2H2O as a liquid substance. So these are in aqueous state, these are in aqueous state as well. This one also aqueous, this is also aqueous. Now if you can see, we do not have any common ion from the reactant and the product, so this becomes our net ionic equation. Now I will leave you with work. I want you to write down the net ionic equation for magnesium plus hydrochloric acid to produce magnesium chloride plus hydrogen gas. This is a gas, this is aqueous, this is aqueous, and this is a solid. So I want you to write down the ionic equation for this reaction. Okay, thank you so much for watching. If it's your first time to watch my videos, please don't forget to subscribe. I would really appreciate your effort and support at the same time. Thank you. Have a good day.